Good evening, everyone. Today we're going to go over milling with Inkscape and sheetcam. Not going to touch on safety equipment, tool holding, feed speeds, bit type, any of that stuff. This video is simply dealing with files, things you want to do or need to do to be able to even get your shapes to work for you, and what you do in sheetcam and how we work this um, workflow. So right here I have a piece that I've drawn up with variable different shapes and types of shapes. Excuse me. And big problem with milling is that we're working with a round bit with a bigger curve. So not everything that we draw is going to come out how we draw it, cutting it with a round bit. So we are going to lose some detail. We're going to need to do some different things to get that. For instance, this slot here on the side, if we had a piece going in here that's this size, uh, where it hits the corners, because there's going to be a radius left from milling, that piece would not fit all the way in. Here's an example of doing reliefs on that. It's called dog boning. So this would make it where a part that's this width with square edges would actually fit tight. There's different ways to do things. We can draw it with a radius. I mean, it's going to come out with a radius. Um, but I was just going to cover here a few ways to work different things. So there's different ways to do your dog boning. Right now I have my snap tools all checked, okay? So I'm just going to drag these circles up here a little bit, and then we're just going to zoom in a little bit. I just want to show you, I'm planning on doing this with an 1/8 inch bit, so these are 126 thousandths. I could just go up here and do like this and cut it out. That would leave me a clean corner, and that's going to remove the material all on one side. I could go here, okay? So depending on how I wanted this to fit, I could leave this side and that side untouched, or I could easily make these untouched, right? So make this end untouched, okay? So if I wanted to, I could just do a control minus and get rid of those, okay? Another way to do this would be to turn off my tools there, and then we're going to drag these over here manually. And it doesn't have to be perfect for this, but we can see if we where that corner is, if we can see that white sticking out, then we're not able to get into it. So if we just position our circle like this, okay, where we can just barely get rid of it, okay, this is going to take a little bit from both sides, and it's not going to leave as big a gap, okay. Um, so, uh, going in, doing it like this will give you less blemish, but it's going to give it on both sides. So we could go like this and then delete these, okay? So either way of doing this will work. Um, it's just personal preference on how you want to do it. In some cases, if you had a shallower piece going in here, you may not want to remove any material from the sides. So it really depends on your part, what you're doing, okay? So I'm just going to go ahead and save this how it is. So we'll just go to Save As. We'll call this milling test file. Already saved it. We'll go over that now. We're going to go into sheetcam and bring our part in. And there's a little bit of difference here how we do this than what we would do if we were doing plasma. So I'm going to open that file. Normally, if I was doing plasma, I would bring it down to the lower left-hand corner. I would want my part to the right and up, to X positive and Y positive in its location to where we zero at. But with milling, I like to center on 0, 0. Reason being, a lot of times we're adding holes or something to a piece of material. And in that case, it's easier to just put an X and line up over top of that X rather than trying to guesstimate if it's going to fit where you're at. So we're just going to bring it in centered on 0. We can see our part came in. The outside shape is red. The inners are yellow, which tells us that we have a closed outer shape and everything is as it should be. Okay. If we had white lines here, it would tell us that we have a broken path. Okay. We didn't get any errors, which is good. So I'm just going to go ahead and do this as if we were just going to cut it out. We'll do a contour cut. I'm going to put it with a 1/4 inch radius, okay, a 1/4 inch bit. So we can see with a 1/4 inch bit, we didn't get tool paths and everything. We can see it didn't come into these corners. This really doesn't look right, okay? So what size bit we use really affects things. And also doing this as a contour cut, how we have it right now, these pieces in the center here are going to break away. And they are possibly going to sling around and break our bit. Also, when we cut our outer shape out, it's going to, possibly move around and get beat up and break the bit. So, at the minimum, if we were doing contour cut, we would want to do tabs on these things. And it's times where you're not going to be able to do very good with tabs. For instance, in a small circle like this, if you put a tab here and a tab here, this is not exactly going to come out round when you get done with it. So probably not the best strategy to do this, okay? One cool thing here with sheetcam, if you just hover over your error, okay, so this will show me what that error is responding to. It zooms in on the problem area, okay? So we can zoom in and see where it's talking about that there's a problem. Okay, so I'm just going to go here and edit this piece, but I'm going to make this now do it with an 1/8 inch bit. Okay, with an 1/8 inch bit, we didn't get any errors because now it will fit a tool path to all of these parts. Okay, and we can see it actually hits our corners all the way. Still isn't going to hit a tight corner like this. There's still a radius to it. Okay, and here it's not doing all of it, and it's not going to fit in here because the size of our bit is our kerf width, and that's going to determine whether it can cut that part of the file. So sheetcam knows whether it can or can't fit it. Just to give you an idea, here's our rectangle, and you can see it would have rounded corners. So if we had a square piece or a rectangular piece trying to fit in here, it's not going to fit. And that's why we did this, because with this, we'd be able to fit our square piece into this corner. Okay, so this would be a good pocket for a dovetail type of joint, a tab and slot joint. So, however, I still am not happy with this. I don't want to have these pieces breaking and flying out on any of these. I don't want to have my part moving around. So I'm going to go ahead and just delete this operation. One of the things I'm going to do is I'm going to go up here to edit contours, and I'm going to move things to different layers because I want to be able to pocket out different areas and do contour cuts on some of it. So that being said, I'm going to move some of these pieces to different layers. So I'm just going to create a new layer. I'm going to call this pockets, okay? And we can move whatever we want to that layer. I'm just going to move most of this stuff. Some of this I'm going to leave just to show you the difference of how it does. And I'm going to pocket that. So we're just leaving our star and this one because I'm going to go ahead and tab these and show you the difference and how the strategy works for doing that. Okay, so now you can see we've got two different layers. Okay, so first thing I'm going to do, I'm going to go do our pockets. We have to be strategic in how we do this. We can't have it cut our outer shape out and then go do the other. We have to be in the order we want them done. Okay, so here I just put 1/8 inch, uh, and not going to get too crazy talking about my settings or what I'm doing, but here I just did the pocket, and you can see what these will do. Now, looking at this, this is 126 thousandth hole, and I'm using an 1/8 inch bit. If I were to pocket that out, it's going to just keep going down and down and down. It's never going to come out to clear the chips out of the hole. I risk getting a lot of heat in my bit and breaking that. So I'm actually going to go ahead and move this to its own layer. And I'm going to call that drill, because I'm going to do a drilling operation on that instead. So we'll go up here. We'll go drilling operation. Uh, so here we go. We're just going to go ahead and do a drill on that now, which will go down a couple times and come out, and go down and then come out. And that will clear the chips out of the bit, and keep it from building heat and breaking. You can have a lot better luck with your life of your bit if you do that. Okay. Next one, we're going to go to contour cut. Okay. I've got the other layer selected. We're just going to go ahead and run with that. I do want to go back here. We're good on that. So we can see this is what it's going to do. Anywhere I have a pocket, it's going to mill the whole piece out, which takes a little bit longer. However, it saves you from having to have a part, flip out of there and break a bit, or have blemishes inside. You could tab things, but where you cut the tab out, inevitably you end up with seeing that in your cut. Now, I still need to add my tabs, so I just selected my outer layer. Okay, I'm going to go up here to edit tabs, and then I can go and add tabs. Generally, I try to add tabs in a big area where I can get a jigsaw or something to cut the tab, hopefully on a straight line. Okay, uh, and then if you're thinking about it, maybe make it somewhere where it's not as obvious that you're gonna clean it up, because I will use like a trim bit on a trim router, and set it to where it can remove that and not cut into my materials. Probably the most effective way to remove tabs and get a good result. So right now we are good as far as our file goes. Okay, as far as our tool path to be able to run this, we don't have anything that's going to break away. Um, no, we don't have this getting cut out, and if we wanted to, we'd either have to run a smaller bit, or we would have to change our drawing to fit the width of our bit. So you got to kind of coincide the two together. With milling, it's a little bit more sensitive, because our kerf width is wider. It's the size of our bit. So I'm actually just going to go in here and go to simulate. Okay. When you do milling, since we are actually having to be the ones telling it what to do, it is a really good idea to run a simulation for a couple of reasons. First off, to see if you did anything wrong. Next one, get an idea of how long it's going to cut, and then sometimes you might want to play with it and uh, try to trim some time, or do something different, that uh, it just works out better a different way. So I'm just going to hit start, and we can watch how this is going to run. You can see it goes down layer by layer. Okay, if we go here and rotate this around, we can see like where our tabs are. Okay, we can also see that these are going all the same thickness all the way down. You can tell how many passes you have, and all that good stuff. Um, so really a useful thing to be able to see how it's going to cut, because you may be pocketing this, want to go 1/8 of an inch down, and instead you messed up, and you'll see now, oh my God, it's going to go all the way through. So running a simulation in sheetcam is great. It's very, very helpful. Okay, um, definitely uh, something I do all the time, and mostly for me is I'm able to watch, how deep it goes, the time. make sure I didn't mess up. But I really want to be able to get an idea of how long it's going to take me. And then if I can fine tune and stay within my safe cutting parameters, as far as what my bits, require for chip load and all of that good stuff, I will do so because be amazed at how much of a difference doing a different step over width or a different cut depth or any of that stuff can have. Sometimes cutting a little bit deeper actually gives you a better finish cut, and just going slower with a deeper cut. Just the way the chips come, it really depends on what you're cutting. So, but keep in mind that's stuff that you're gonna end up playing with. And for me, after doing this for so many years, I know, um, just like with plasma, one of my best tools I have is not just watching the machine, but it's actually listening to it. When you're milling, you're going to hear, chatters when the thing's bogging. Um, just being able to look at your chips. Are you getting dust or are you getting actual chips? Uh, the reason we focus so much on chip load with milling is with a properly sized chip, your bit is actually cutting rather than rubbing your material. And then the chip actually absorbs the heat. And when it's evacuated, the heat from the cut is going into your chip, not so much into your bit. If you're doing too small of a chip, a lot of times you end up double cutting your chip. You're making dust, you're double cutting and you're rubbing, and that makes heat in the bit and causes the bit to break. If you're doing too big of a chip, you're going to deflect your bit and bog and potentially break your bit again. So just trying to get that happy medium. There's plenty of feed speed charts out there, different softwares that have stuff built in. And there's as many variables as there is, uh, you know, different scenarios of different materials and whatever. I mean, temperature, bit type, bit angle, flutes, how many flutes, coating, coolant, no coolant, blowing air on it, what's the temperature of the material, how long is the cut, you name it, how rigid is the machine, how much power do you have, how uh, true is your bit turning, everything and anything affects us with when it comes to milling. So definitely requires a little bit more thinking, um, but it's really, really a rewarding process when you get parts that come off the machine and they're just ready to go and they look beautiful. You've got different materials that you don't have to paint or powder coat or anything after you're done. You just take it right off the machine and it looks awesome. That's great, and the accuracy you get. Um, Plasma's good, and yes, you can fine tune it, but generally, plasma itself, because it cuts an angle, um, it does have a taper to the cut, and that varies from side to side on the actual cut. It is only so accurate. Where milling, when you're running at the proper speeds and feeds and the right bit, you get nice and true edges and accurate holes and all of that good stuff. So you'd be amazed. The same machine you cut with plasma, and you go, man, I'm not getting that great of cuts, but just switch a spindle on there, and you're blown away. Because most of the time, it's not the machine per se; it's all the variables. But let me know what you guys think. This is a video. I'm going to be doing a bunch more uh, training slash tutorial videos. But this one is basics on CNC milling. So let me know what you think. Thanks.